What do you remember about the unit circle? Hopefully you remember that the word unit has uni in it, which means one. So when we're talking about a unit circle, we're talking about a circle where the radius is 1. So if we understand that, that means if we start at the origin and we go out a distance of 1 to this point here, that the ordered pair would have to be 1, 0. If we go up 1 from the origin, it would be 0, 1. If we go left 1 from the origin, it will be -1, 0. And if we go down 1 from the origin, it would be 0, -1. We know that on our circle, each of these locations also represent angles. So this angle, as we did in a previous video, was 0 degrees or 360 degrees. This angle is 90 degrees. This is 180 degrees. And down here we have 270 degrees. We could also continue by putting these into radian measures, which again were explained in a previous video. So 0 degrees is 0 radians, and 360 degrees is 2 pi radians. 90 degrees is pi over 2 radians, and 180 degrees is pi radians. And since 270 is 3 times 90, then it will be 3 times pi over 2 for our 270 degree angle. We also found in a previous video the values in quadrant 1 using special right triangles. So as an example, the reference angle here was 30 degrees, and so we put 30 degrees So we have 30 degrees. We know that 30 degrees is pi over 6 radians. And when we did the calculation, we found out that we had radical 3 over 2 and 1/2 as our ordered pair. And we kept going. So the next angle up was 45 degrees. 45 degrees was pi over 4, or basically 180 divided by 4. And the ordered pair that we had for that one was radical 2 over 2 and radical 2 over 2. The next angle that we had up was 60 degrees, and it was equivalent to pi over 3 radians, and the ordered pair that we had for that particular point was 1/2 comma radical 3 over 2. It turns out that this is enough for us to figure out the rest of the quadrants. So let's go ahead and figure out what's going to happen for the rest of these. So let's start by finding out some things about reference angles. So first of all, if we had a reference angle in quadrant 1, suppose that we had our 30-degree reference angle, this is what it would look like. Remember that this reference angle is going to be between the x-axis and the terminal side. So it's really the shortest angular distance between the x-axis and the terminal side. So let's say that we were given a different angle. Suppose that we're given this angle, which I'm stating is 150 degrees. So this angle is 150 degrees. And I asked you what the reference angle was. So the reference angle would be this green angle that I'm drawing here, because it represents the shortest angular distance between the x-axis and the terminal side. So our reference angle for 150 degrees is 30 degrees. Suppose that we were to draw that on a different version of the coordinate plane. So here's our reference angle, and we're saying that this is 30 degrees. Notice that if we go to the left and we go up, that we've now formed a right triangle. So we have a 30, 60, 90 triangle. On a 30, 60, 90 triangle, and please excuse the triangle, but on a 30, 60, 90 triangle, we know that the side opposite the 30 is 1, the side opposite the 60 is radical 3, and the side opposite the 90, which is the hypotenuse, is going to be 2. So if we need to find the sine of each of these, or the cosine, we could definitely find that. Keep in mind though that even though technically this is incorrect writing this because distance is not negative, in the second quadrant we had to go to the left. So that means that this should be a negative radical 3. So let's say we want to find the sine of that angle. So sine of 30 degrees. Sine is opposite, which is 1, over the hypotenuse, which is 2. So it's going to be 1 over 2. Let's say we want to find the cosine of that same angle. So the cosine of that same angle would be the adjacent, so that's negative radical 3 over the hypotenuse, which is 2. So negative radical 3 over 2. So what does that tell us? At 150 degrees, we're going to have negative radical 3 over 2 and 1/2 as the ordered pair. Remember, on the unit circle, on our previous video, we found that cosine was the x value on the unit circle, and sine was the y value on our unit circle. How does that compare with what we had at 30 degrees? Well, at 30 degrees, we had radical 3 over 2 and positive 1/2. So if you notice, the only difference between the reference angle in the first quadrant and the reference angle in the second quadrant is what happens with the x value. So the x value is going to be the opposite. So let's say that we found other reference angles. What would the reference angle for, what angle would have a reference angle of 45 degrees in the second quadrant? So if this is 45 degrees, that means that the original angle had to have been 135 degrees because they're going to be supplementary. So we're going to say 135 degrees, and this is going to be related to 45 degrees. Remember that we had the following relationship. So we had over here 30 degrees, or pi over 6, and that the ordered pair was radical 3 over 2 and 1/2. Remember also that over on the other side, we had 150 degrees, and the ordered pair was negative radical 3 over 2 and positive 1/2. At 45 degrees, or pi over 4, we know that from the previous video, we got radical 2 over 2 and radical 2 over 2. So that means for our reference angle in quadrant 2, the only difference is the x value should be negative. So it should be negative radical 2 over 2 and radical 2 over 2. So if we continued, that means that our reference angle here would have to be 120 degrees. Because again, I'm sorry, our angle would have to be 120 degrees to have a reference angle of 60 degrees. And we know that that's related to our 60-degree reference angle here, which had an ordered pair, sorry, it was pi over 3, and had an ordered pair of 1/2, comma, radical 3 over 2. So our value over on this side would be negative 1/2, radical 3 over 2. If you notice, this pattern follows what we know about coordinates. In quadrant 1, we know that we have a positive x value and a positive y value. In quadrant 2, we know that we have a negative x value and a positive y value. If you notice, that's what's happening on each of these. So really, we can find the rest of the values very easily. One other point that I wanted to make was that we can also multiply the quadrant 1 reference angles by a certain number to get the quadrant 2 angles. So as an example, if you take 60 and multiply it by 2, then you're going to end up with 120. So in other words, if 2 times 60 gives you 120, then 2 times pi over 3 should give you 120, because again, pi over 3 and 60 are the same. So that tells us that the radian measure here was 2 pi over 3. If we follow the same reasoning, 45 times 3 gives you 135. So this angle is really 3 times 45, or 3 times pi over 4. Similarly, 5 times 30 gives you 150. So 5 times pi over 6 should give you 150 also. If we follow the same reasoning here, we'll notice that our reference angle here needs to be 30 degrees. So that means that this is going to be 210. Our reference angle here needs to be 45 degrees. So if we add that to 180, that's going to be 225. Our reference angle here needs to be 60 degrees. So if we add that to 180, that gives us 240. And so we have our angles in quadrant 3. So remember that the values repeat over and over, it's just that the signs change. So in this quadrant we had positive, positive. In this quadrant we had negative, positive. In this quadrant we should have negative, negative. And so when we write our values for our points, both the x and the y are going to be negative values. So for our 30-degree reference angle, which is 210, we should have negative radical 3 over 2 and negative 1/2. For our reference angle at 45 degrees in quadrant 3, which is 225, we should have negative radical 2 over 2 and negative radical 2 over 2. For our reference angle of 60 degrees in quadrant 3, remember this is basically just negative, negative, so it'll be negative 1/2, comma, negative radical 3 over 2. In terms of our radian measures, 210 is 7 times 30, so this angle is going to be 7 times 30, which is pi over 6. So 7 times pi over 6. 225, let's see, that's 5 times 45, so this is going to be 5 pi over 4. 240 is going to be 4 times 60, so that would be 4 times pi over 3. So let's get our angles in this quadrant 4. So here we want a 30-degree reference angle. So let's see, that's 30 before we get to 360, so that's going to be 330. We want our next reference angle to be 45 degrees away from the x-axis, and so 45 before we get to 360 would be 315. We also need a 60-degree reference angle. So our 60-degree reference angle means we're 60 away from 360, which means that we're at 300. So let's put our values in. Remember also that in the first quadrant we said the ordered pairs were positive, positive. Second quadrant they were negative, positive. In the third quadrant, they were negative, negative. And in the fourth quadrant, they have to be negative, positive. So for 330, that's related to our 30-degree reference angle. So we're going to put the values in, just make sure the signs match. So this would be negative radical 3 over 2 and 1/2. For 315, that would be negative radical 2 over 2 and radical 2 over 2. For 300, that would be negative 1/2 and radical 3 over 2. So let's figure out our radian measures. 330 is basically 11 times 30. So this is 11 times what 30 is, or 11 times pi over 6. 315, that's 7 times 45. So 45 is pi over 4. So this is basically 7 times pi over 4. 300 is 5 times 60. So that's going to be 5 times pi over 3. So that's how we're going to end up with the rest of the unit circle. So let's put it all together. So we have our quadrantal angles, which are 0 or 360 degrees, which can also be written as 0 or 2 pi radians, and then also 90 degrees, which is pi over 2 radians. 180 degrees is also a quadrantal angle, and it is pi radians. 270 degrees is 3 pi over 2 radians. And then we can fill in our values on the unit circle. As long as we know quadrant 1, we can figure out all the other quadrants. So our reference angles, first we have a 30-degree reference angle, then we have a 45-degree reference angle, then we have a 60-degree reference angle. Since pi is 180, and 180 divided by 6 is 30, this is pi over 6 to get 30 degrees. 45 would be pi divided by 4. In other words, 180 divided by 4. 180 divided by 3 gives us 60. So pi over 3 is our reference angle in radians. We can continue getting the rest of our reference angles as well. So we know that over here in quadrant 2, if we are 30 away from our x-axis, that really we're at 150 degrees. The next reference angle of 45 degrees is going to have an actual angle measurement of 135 degrees. And by the same reasoning, 120 degrees is the other angle that we'll have. And if we can keep going, just like we did in the previous slides, that we could do 180 plus 30, that would be 210, because we have our 30-degree reference angle. Our 45-degree reference angle would put us at 225 degrees. Our 60-degree reference angle would put us at 240 degrees. And then we can keep going into quadrant 4. This should be 300 degrees from our previous example, and then 315 degrees and 330 degrees. We can find the radian measures for each of these. Basically, for pi over 3, we multiply that by 2, and that gives us this value here. For 45 degrees or pi over 4, we multiply that by 3, and that gives us 135. 150 times 5 gives us, 30 times 5 gives us 150, which is 5 pi over 6. 210 is going to be 7 pi over 6. 225 is going to be 5 pi over 4, and 240 is going to be 4 pi over 3. For 300, that's going to be 5 pi over 3. 315 is 7 pi over 4, and 330 is 11 pi over 6. We know our ordered pairs as well. So at 0, 360, it's 1, 0. At 90 degrees, it's 0, 1. At 180, or pi, it's going to be 1, 0. At 3 pi over 2, it's -1, 0, -1. And we can figure out our special angles, what those points would be. So this point at 30 degrees, we know is going to be radical 3 over 2 and 1/2. At pi over 4, it's going to be radical 2 over 2 and radical 2 over 2. At pi over 3, it's going to be 1/2 and radical 3 over 2. From what we know about our quadrants, the first quadrant is positive, positive. The second quadrant is negative, positive. The fourth quadrant is negative, negative. And, sorry, the third quadrant is negative, negative. The fourth quadrant is negative, positive. Or, sorry, positive, negative. So all the values that we had in quadrant 1 are going to repeat for those reference angles. We just have to make sure the signs are right. So 150, which had a reference angle of 30, is going to have the same value. So it's going to have that radical 3 over 2. But in this quadrant, the x values are negative and the y values are positive. Our next reference angle for 135 was 45. So it's going to have negative radical 2 over 2 and radical 2 over 2. At 120, that reference angle was 60, so that's going to be negative 1/2 and radical 3 over 2. So in the third quadrant, they're both negative, so our third degree reference angle would be negative radical 3 over 2 and negative 1/2. The next value, again, would be our 45 degree, which would be negative radical 2 over 2 and negative radical 2 over 2. Our 60 degree reference angle would be negative 1/2 and negative radical 3 over 2. Our 60 degree reference angle in quadrant 4 would be positive, negative, so that would be positive 1/2 and negative radical 3 over 2. 7 pi over 4, that would be 45 degree reference angle, which would be positive radical 2 over 2 and negative radical 2 over 2. And finally, our 11 pi over 6, or 330 degrees. Remember that this one had a 30 degree reference angle, just like how we had a 30 degree reference angle here. So it's going to have the same values, but we're just going to change the signs. So it'll be negative radical 3 over 2 and also, positive radical 3 over 2 and negative 1/2. Because again, in this quadrant, it's positive for the x values and negative for the y values. In a future video, I'm going to show you guys how you can memorize the unit circle. Besides coming up with it like how we just did, there are a few strategies that we can use. You just basically pick the one that works best for you.